So on part A, you could just multiply across and you'd get 60 over 24, right? But then you would have to reduce. So a lot of times, I would say almost every time, it's actually going to be easier to reduce common factors first and then multiply. Especially when your numbers, if we were to multiply those and it was something much bigger than 60 that we weren't at all familiar with the factors of, and something much bigger than 24, it would be harder to find common factors. So you're better off keeping it kind of stripped out first and start reducing anything in a numerator that reduces with anything in the denominator. So what jumps out at me is 6 and 3. 6 and 3 both can be divided by 3, which will make 2 and 1. 10 and 8 are both divisible by 2, which will make 5 and 4. And then, no one says one has to come from one fraction and the other one has to come from the other. Even within this first fraction, 2 divided by 4 is 1 over 2. So by the time that's all said and done, you've got 1 times 5 up top, which is 5, and 2 times 1 on the bottom, which is 2, and there you're done. Okie doke. So, in B, same idea, it just all has to be factored first. So the steps for simplifying a single fraction are factor cancel. Those are really the same steps for multiplication, factor cancel. So, Faye, what does this factor into? Okay, on the denominator, what does that factor into, Eric? Very good. X minus 3x plus 2. And the top right, Morgan, what would you do with that? Yep. Perfect. So that was just a GCF one. So right in this problem alone, we had a special pattern. Then we had a basic trinomial guess and check. Then we had a GCF. And on the denominator, what would you factor that into, Angie? So good, except for not 6x squared, just 6x. And then x minus 2. Good. I'm just rewriting what I wrote on that other sheet, so it's right in the top corner. Your steps, your options are GCF first and foremost, no matter what the problem. And then your second step is to either look for the special pattern or guess and check or grouping. So now that we've got that all factored, anything that overlaps, numerator, denominator, will make 1. So x plus 2 divided by x plus 2 is a 1, so cross those out. You have an x minus 2 up here and an x minus 2 down here, so x minus 2 divided by x minus 2 is 1, so cross that out. You have an x over an x. Do you see? Very important though. This x is not part of a binomial. Do we see that? So this x and this x, which are not parts of binomials, they're part of a monomial, and that's fine. They can be canceled, whereas this x and this x absolutely cannot be canceled. Is that clear? This x is part of a binomial, this x is part of a binomial. They cannot be canceled, but these x's can be. 3 divided by 6 reduces to 1 divided by 2. And I guess the main thing to be aware of with this is once you've got a lot of things crossed out, make sure you very carefully go through and don't miss anything. So that's gone, you've got a 1 times an x plus 5, which is just x plus 5 up top. And in the denominator, you have an x minus 3 times 2. So the 2 would go out in front, and you have x minus 3. And that's your simplified answer. It'll depend. If it was open response, doesn't matter. If it's multiple choice, they might not. Okay? Now, the next exercise is A and B below. These are all what? Monomials or polynomials? Monomials. So there's no factoring here. You don't factor monomials. So you're just going to start canceling things. So if I focus first on my numbers, what do you see that can be canceled? Owen? Numbers first. Or reduced. What can be canceled about that? They both what? Okay, so forget the x's. I'm just doing numbers. But the 10 and the 5 will become what and what? 2 and 1. What other numbers do you see, Jack? B. Yep, 8 and 6 becomes 4 and 3. Anything else with numbers? Say it again. The 4 and the 2? No, because they're both in the numerator. Good question. So it has to be something from the numerator with something from the denominator. So we're done with the numbers. Now, with the letters, we've got to think exponent rules, right? We have y to the 7th with y to the 3rd. Which ones are going to cancel out completely? The y to the 3rd, yeah. All 3 of these will be gone, and we're going to take with them 3 of the 7 that were there. It was leaving how many? Y to the 4th. And then you have an x squared and an x cubed. So which one of those is going to cancel completely? The x squared. Both of those are going to cancel with 2 of these, leaving how many down below? Just x to the 1st. So, on your top you've got 4 times 2, which is 8y to the 4th, over 3x. Does that make sense? Okay, so that's how we'll do a monomial. We're not going to go and do B as well unless we have time. C brings us back to polynomials. So factor, 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 factor. So what does that first one factor into, Natalie? It sounds like you're trying to guess and check sort of factor, like you're trying to create 2 binomials, but there's a GCF here. What is the GCF that can come out of both of those? 2x. And when you take a 2x out of this one, what's left? X plus 6. Over the denominator factors, Chris Brooks. Good. Times over here on the numerator. Take a minute to try to factor that. Vince, what do you think? Very good. X minus 6 and x plus 2. And on your denominator, Tess, how would you factor that? Perfect. X plus 6, x minus 6. Now, Jack Taylor, what cancels? X plus 6 on the left and x plus 6 on the right. X minus 6 on the top, X minus 6 on the bottom. X plus 2 on the top, X plus 2 on the bottom. One and 2. Perfect. So on my top, I just have 1x, so x. And on the bottom, I just have 2. Good? Okay. With dividing fractions, you want to keep change flip first. You want to immediately change this into multiplication. So what that means, keep this fraction the same. It means change division to multiplication. And it means flip to the reciprocal of the other one. And then do everything else the same as you've been doing with multiplication. Division is essentially multiplication. You just have to flip it first. So, 1 is not factorable. N plus 9 is not factorable. The top right is factorable. I can pull out a 3. I'm left with n minus 6. And the bottom right is not factorable. 6 minus n. What can I do to simplify this out, Jason? Ask your classmates. Who wants to answer his question? Corey.
They kind of cancel, but you gotta multiply that.
They kind of cancel, but you gotta they make negative 1. So you can cross them out and then throw a negative sign up there in replace of that. So your numerator is 1 times 3 times a negative, so it's just negative 3. And your denominator is n plus 9. Yep. Can her classmates answer that question? Can we reduce the 3 and the 9? Raise your hand. Well, hold up 1 if you think yes, 2 if you think no. 1 is yes, 2 is no. Seeing a lot of no's, which is good. You can't. Now, why can't you? What was my explanation, Lucas? Right. If you were crossing off the 9, that would be a big no-no because that's a piece of a polynomial. And you can't do that. Good. Okay, flip it over. So, we again have division. This time it's just monomials. So we keep change flip and we don't have to worry about factoring. So we're going to keep the first fraction, change the division to multiplication, and flip the second fraction. And then we're going to start reducing. So I want everyone to do that on your own now. Reduce that and then we'll see what kind of answers come up. Hopefully only one. All right. Kate, what'd you get for your final answer? Say it again. Like that? Say it again. Oh, 3x to the negative 6? Did you say 3x minus 6, or was I hearing things? Okay. So that would be 3x to the negative 6. That was your final answer? Okay. Someone get anything different? Angie, what'd you get? Stuck where? Say that again. 5x squared over, okay. So you didn't do anything to that, but you reduced this one by 3 and 3. So that's all you could do. Like this one and this one, or this one and this one? These two. Can you add them? Definitely not adding. Because if it was x squared up top times an x to the 8th up top, then you could add them and make it x to the 10th. But they're not both up top. Really what it is x squared divided by x to the 8th. So what would that become? Like if we were doing x squared divided by x to the 8th, what would that be? X to the what? What's the rule with what to do with those exponents? So what would it be? Right. I would definitely do that. Slash your 5s and slash your 2s. Yes. Okay, we'll come back to that. Did anybody have a different final answer? Who haven't I heard from? Lucas B., what'd you have? You had the exact same thing? Georgia, what'd you have? Three x to the positive 6. Okay. Lucas. Anybody else? Okay. I'm not going to comment on if anything's wrong with these two, but I know they're not finished. So if those were your final answers, so 3 gives the Larry opportunity to cancel things out. Right? 3 over 3. Based on what Angie told us, you can kind of see all of those numbers are wrong. There are definitely no coefficient out in front other than 1. Because those 3s would cancel. Now, when you do that, this one and this one become the same answer. And this one is incorrect. So, something to think about here. So, when you do division and you subtract your exponents, whether you get a positive or negative exponent, that is in a numerator, right? 2 minus 8 is negative 6. It's x to the negative 6. That's in a numerator, so it's technically over 1. And then because of the negative exponent, you have to move that to a denominator, correct? That's one way of looking at it. So it should be a positive 6 in the denominator. These are the right answers, these two. Kate, what it looks like you did was, because there's two ways to look at this. You can do this divided by that and subtract your exponents, but x to the negative 6 would be in the numerator. That's one way of looking at it, is via exponent rules. The other way is thinking, okay, this has 2 and this has 8. So all 2 of these are going to cancel, with 2 of the 8 of these leaving only 6 of these in the denominator. Does that make sense? Okay? The y to the 7th, y to the 5th, the 5 completely cancels with 5 of those 7, leaving only 2. And then we obviously got our variables all taken care of, or our coefficients all taken care of. Okay? Raise your hand if you got that right. Okay, that's good. We definitely, it's going to take some fine tuning, but that's over half of you, so that's good. In C, division, first we're going to keep change flip. And once you keep change flip, now go on to your next step and start factoring, and then worry about what you can cancel, and then we'll get back to each other. Alexa, what did you get for your final answer? X plus 5 over what? 4 parentheses x minus 4. Okay. Mike, what'd you get for your final answer? Oh, you're not there yet? Okay, keep going. Just tell me when you're ready. Alexa, can you take one and test it? What's that? Elena, what'd you get? You got this one? Mike, one thing I noticed about yours is that you'd still take out a 2 and you'd have a 4x minus 1. I don't think that would help you at all because it wouldn't cancel anything else, but let's see what goes on here. So this one is x plus 4, x minus 2. On the denominator, we can take out an 8. We're left with x minus 2. On the numerator, we can take out a 2. We're left with x plus 5. On the denominator, we have a special pattern, x plus 4, x minus 4. So, x plus 4 and x plus 4, gone. X minus 2 and x minus 2, gone. The 2 and the 8 can become 1 and 4. And that would be all we can cancel. So up top, we've got an x plus 5. On the bottom, we've got a 4 and an x minus 4. So, did you know what you did wrong, Mike? What was it? You didn't factor it out? Well, no, I don't know, though, because even if you did further, that wouldn't cancel out. Gotcha. So your homework is coming around, correcting it.